Okay, so in this video, we want to find the function f of x if its second derivative is equal to the root of x minus 3 all squared, and f of 0 equals negative 1, and f of 1 equals 1 over 15. And you may ask, well, why do we need here two initial conditions? Well, we'll have to go back from the second derivative to the original function, so we have to undo two differentiation, which means integrating twice. But when we integrate twice, this will return two arbitrary constants of integration, which will require two equations, hence the two initial conditions. So given the second derivative, to specify a unique function, we need to have two initial conditions. So let's get going. Let's go back from the second to the first derivative by integrating both sides once. So we'll integrate the second derivative with respect to x, which of course will be equal to the integral of this function as well with respect to x, as both are equal. They clearly have the same integral. Well, we can't integrate over this, as it is a product between root of x minus 3 and itself, but if we multiply out, then we'll use the power rule. So let's square this. So root of x times itself is x, minus 3 root of x minus 3 root of x, minus 6 root of x. And I will not write root of x, but thinking of the power rule, instead I will write x to the power of 1 over 2. And finally, negative 3 times itself, plus 9. And now we'll find both indefinite integrals, and we know from the previous video that we only need to add a constant of integration on either side. As we're trying to solve for ultimately f of x, we'll add a constant on the right hand side. So if you integrate f double prime, you of course get f prime of x, as the derivative of f prime is f double prime. So we have our antiderivative here of f double prime, which equals power rule here, so x will give us x squared over 2. Minus 6 is a constant multiple. Power rule in x to the 1/2. If you add to the 1/2 1, you get 3/2. You divide by 3/2, which means you multiply by 2/3. Plus, and the integral of 9 is 9x, plus our constant of integration. Well, let's simplify a little bit, right? 6 over 3 is 2, 2 times 2 is 4. So we have that f prime of x is equal to x squared over 2 minus 4 x to the 3/2 plus 9x plus c. So now we went from the second derivative to the first derivative. Well, we want to go one step further from the first derivative to the original function. So we have to integrate both sides one more time. So let's integrate with respect to x, of course, both sides of our equality. Again, we have an equality between two indefinite integrals. We can only add a constant on either side. As we're trying to solve for f of x, ultimately we'll add a constant on the right hand side. If you integrate f prime of x dx, you of course get back f of x, as the derivative of f of x is f prime of x. And again here the power rule. We'll have your x cubed over 3, but 3 times 2 is 6, so it's x cubed over 6. Minus 4, power rule again. If you add 1 to 3/2, you get 5/2. And if you divide by 5/2, you multiply by the reciprocal, which is 2 over 5. Plus, power rule on x, x squared over 2. plus c is a constant, so the integral of c is cx, plus the other arbitrary constant. And I'm calling it d, but of course you can call it any other letter than c. And now we have f of x. Let me simplify here this term. So the function up now to two constants of integration is x cubed over 6 minus 4 times 2 is 8, so 8 over 5, x to the 5 over 2, plus 9 over 2, x squared, plus cx, plus d. Well, so by integrating twice, we went from the second derivative to the original function, as we undid the two differentiation, but we have to solve for these two constants. Well, now we can use our initial conditions. As we have the two constants, we'll need two equations, which will be given by these two conditions. Let's use the first one. F of 0 is negative 1. So let's plug in. So f of 0 is negative 1. Let's replace x by 0. This will be 0, 0, 0, 0, and we're left here with simply d. And so d is negative 1. So now we can replace d by negative 1. And with the other initial condition, we'll solve for the other constant of integration. And the other condition was f of 1 is 1 over 15. So f of 1 is 1 over 15. And now we will be replacing in the equation x by 1. So I'll get 1 over 6 minus, well, 1 to any power is 1, so minus 8 over 5, plus 9 over 2, 1 squared is 1, so plus 9 over 2, plus c times 1 plus c, minus d. Plus d, which is minus 1, so minus 1. And now we'll just simplify this, and we'll have the value for c. So 1 over 15 equals, and we'll do two things. Over a common denominator, so this will give us 5 minus 48 over 30 plus, well, 1 is 2 over 2, and so 9 minus 2 is 7 over 2, so plus 7 over 2. And of course, plus c. So what do we have? Well, 1 over 15 equals 5 minus 48, that's negative 43, over 30. Let's put this over 30 as well. So times 15 over 15. 7 times 15, well, 7 times 10 is 70. 7 times 5 is 35, so it's going to give you 105. Plus, of course, c. So we have 1 over 15 equals, this will be out of 30. Well, if you add to 40, 60, you get 100. And it'll go up to, from 3 to 5, 2, you get 62. So this is simply 62, plus of course c. So 105 minus 43 is 62. And here we can cancel a 2 as both 62 and 30 are even numbers. So we have then what? Well, that 1 over 15 is equal to 31 over 15 plus c. Subtract 31 over 15 on both sides, and you'll get that 1 over 15 minus 31 over 15 equals c. But 1 minus 31 is negative 30 over 15 is simply negative 2. And now we have the value for c. And we can go back and give our final answer. So f of x is x cubed over 6 minus 8 over 5 x to the 5 half plus 9 over 2x squared plus cx, but c is simply negative 2. So we get negative 2x, negative 1, and this is now our final answer. So, the unique function that satisfies the three conditions, that the second derivative is the root of x minus 3 squared, and whose value at 0 is negative 1, and whose value at 1 is 1 over 15, is the given function, x cubed over 6 minus 8 over 5 x to the 5 half plus 9 over 2x squared minus 2x minus 1. And that's it.